day math learners, in our day-to-day life, we are dealing with quantities that change in relation to one another. You learned from your previous lessons that these quantities are referred to as variables. In mathematics, these variables can be represented by symbols or by any letter in the alphabet. Let us begin this lesson by determining the variables in real-life situations. How do we know which variable is independent and which variable is dependent? Dependent variable is a variable that is affected by the independent variable, and it changes in response to the independent variable. In a relation, dependent variable depends on the independent variable. It is generally represented by the y variable, or what is referred to as y value. While independent variable is a variable that will change by taking on different values. It changes independently. In a relation, independent variable controls the dependent variable. It is generally represented by the x variable, or what is referred to as the x value. So look at this scenario. In this scenario, which must happen first before the other occurs? Which variable controls the other? And which variable depends from the other? If you can see, the amount of money Robert earned is actually a function of the number of hours he works. For instance, if he earns 40 for every hour he works, then he earns 200 for working 5 hours. The relation can be represented using the equation f of x equals 40x. F of 5 equals 40 times 5. Therefore, f of 5 equals 200. And that is the amount he earns if he works for 5 hours. Is it possible to know how much to pay him? We do not know how many hours he worked. The answer is no. In order for him to get paid, he needs to work for a certain number of hours first. So, the amount of money he earns is a function of the number of hours worked. In this scenario, the number of hours Robert worked is the domain of the function, while the amount of money he earns is the range of the function. Now, let us first define the domain and the range. The domain of a function is the set of all acceptable inputs. Generally, domain is the set of x values or the abscissa of the ordered pairs of a function. The range of a function is the set of resulting outputs. Generally, range is the set of y values or the ordinate of the ordered pairs of a function. There is a common misconception. We can use any number for the inputs or domain of a function. That is very wrong. In fact, we must inspect the function and determine any limitations on the domain. Now here is the misconception. I cannot just use any value. F of x equals 3 over x. How will you determine the domain and range of the function from a given set of ordered pairs? A. Example. Determine the domain and range of the function for the set of ordered pairs 0, negative 3, 2, 5, negative 1, negative 1, negative 3, 15, and 1, negative 1. So for sure, you can determine the domain. The domains are 0, 2, -1, -3, and 1. These are what we call the X values or the abscissa. The range are -3, 5, -1, and 15. These are the Y values or what we call the ordinate of a function. How are you going to determine the domain and range of a function using the mapping or the mapping diagram? Example, determine the domain and range described by the mapping below. You observe the mapping diagram and determine the domain and the range. The domain and range are easily recognized in the mapping. The domain is the first set of numbers in the diagram, and the range is the second set of numbers in the diagram. So the domain is 0, 4. The range are 2, -8, or -8, 2. How about domain and range of a function given the notation or equation? Example, given this function, f of x equals 3 over x, 0 cannot be substituted for x since division by 0 is undefined. So, f of x equals 3 over x. If it is f of 0, that is equal to 3 over 0, and that is undefined. Hence, the domain is the set of all numbers except 0 in set notation. Since you cannot take 0 as your input, then 0 is also not a possible output. Hence, the range is the set of all real numbers except 0 in set notation. Example, determine the domain and range of the function f of x equals 2x plus 1 over x plus 2. Now you have solution here. The denominator x plus 2 cannot be equal to 0 since division by 0 is undefined. Determining the value of the restriction, we get x plus 2 equals 0. The denominator cannot be 0. I mean x plus 2 is not equal to 0. The denominator cannot be 0. X plus 2 minus 2 is not equal to 0 minus 2. That is addition property of equality. X is not equal to -2, and that is additive inverse. Hence, the domain is the set of all real numbers except -2, because -2 will make the whole denominator become 0. In set notation, to find the range, we need to get the inverse of the function by following the procedures below. The inverse of the given function is f raised to the -1 times f of x equals -2x plus 1 over x minus 2. By inspection, the inverse has limitation 2. The denominator x minus 2 must not be equal to 0. This restriction applies to the possible outputs or range of the original function. X plus 2 is not equal to 0. The denominator of the inverse of the function should not be equal to 0. X plus 2 minus 2 is not equal to 0 minus 2. That is addition property of equality. X is not equal to -2, and that is additive inverse property to simplify. Hence, the range of the original function is the set of all numbers except 2. In set notation, we have okay, that's all for today, math learners. See you in your next video lesson. I hope you have caught up so many ideas in our video presentation. Please refer to the SLM for your activities and assessment. Thank you for watching and listening. Stay safe and healthy. God bless.